So Raju and Saurabh, am I audible, right?
Yes, sir.
Okay, okay, fine. Yeah, because this is the discussion class, right? So you can ask anything regarding the course, lectures, and tutorials.
So can we directly use like sigma n xn, like if or sigma n square, in the generating functions at at some step we get like at times we get sigma n xn or sigma n square, term. So can we directly use their expansions, or would we have to show those steps as well?
Which one? Summation n the formula of summation n square. I did not get what you were saying.
As in like summation nan, right? Or summation n square an x to the power n, right?
Huh?
So
Huh?
at times we get to this stage. So can we directly write the formulas or like their generating functions like sigma n square xn, or do we have would we have to show those steps? So the steps for like breaking down sigma n square as well. Like sigma n square, we'll have to break down sigma n into n minus one an plus nan, and then further show the steps.
Yeah, I don't know any formula. So how you will write that one? Because if you write
I
that
mean,
n
like.
into n minus
Uh,
one, then actually it comes from the derivative, right?
Yeah. So I'm saying that instead of just like first breaking them down and then writing the steps, like we'll show that it's a derivative of something, and then we come to the final generating function. Can we directly write a generating function from sigma n square an
Okay, okay.
as
No,
we
no, no.
practiced?
I think better to avoid that. So just write whatever is basic one, because
Okay.
otherwise the TA have means who will check it? It can be me or the TA. Then they have to verify that it is right or wrong, right? So it will take time. So better to just do all the steps. You will have time because you will have 1 hour time. So it is sufficient, I think, for 3 questions.
Okay, sir.
Okay, so better to write each and every step. Right. Okay, good. So other students, please ask your doubt or any question. You can ask any question from the lectures as well, and also from tutorials.
Sir, can you explain Catalan numbers?
That I did not teach, right?
Uh, wait, no, sir, but I think it was like there in
Right?
like the notes that you gave.
No.
No, like in one of the exercise, like in one of the exercises, it was there. So I thought we had to do it ourselves.
Okay, you can read that one, but it is not from in our course. So I so just see the content. So I send you one book, right? And that in the class notes I have written all the topics which is in the syllabus only in our course. So we will not ask anything from the catalog number. Catalog number.
Okay.
So anyway, we always encourage you. You can read as much as possible, because if you read something, then your knowledge. So you will gain your knowledge, right? Okay, the students, please ask. So if you have any doubt, you can just ask regarding the course, the lectures, and also from the tutorials. You can ask any questions from the tutorials as well. You don't have any?
Sir, quizzes of 1 hour or 45 minutes?
1 hour.
And extra time for scanning, or it is included in that?
No. So there will be extra time, because actually it is during the lecture time, right? 9:30 to 11. So you will get the almost whole time. So we keep it as 1 hour plus 20 minutes, and maybe 10 minutes for the buffer because someone maybe have some internet issues. So I will
Okay.
send email now. Only I will send the email with all the details. And questions will be not very difficult. That will be the theory based only. The theory based means which we actually taught in our course, lectures and the tutorials. So at least 2 problems I will give from the lecture notes and the tutorials. Just we'll change the digits, that's all. Like, I
So
mean
how
that
many questions can we expect?
3
Three questions.
3 questions only. 3 questions, 1 hour. You will have sufficient time to write. Because these questions are very long, no? Because it is calculative, you need time for that. And also that online link, you can use that, where you can find the solution by putting the value of x and that power series, right? So you can use that one.
Excuse me, sir.
Sir, how
Yes.
to use that? Can you please show in one question? Or you
How-
can, or we should just go through that.
Because you have laptop, you have mobile, right? You can just type that. You can just copy and paste the link. That's all. We will provide the link as well. Don't worry.
Excuse me, sir.
Yes, yes.
The previous class recording is not available. It's showing that it's not available.
Yeah, I send you. It is available in the Impertus as well as it is available here. I have actually deleted the previous one because there was some internet issues and so I just cut those part and then I again post in the image team only. You can find it. I can show you. So this is our no. You can see this is the lecture note, lecture 15 video, lecture 16 video.
Okay, sir.
Okay, I just removed from here. Yeah, where from this. I have just removed these two because of the internet problem, na. So those parts I just removed. Yeah, so you people are asking only the query. You don't have any questions from the lectures and the tutorials.
Sir, hello, sir.
Yeah.
Sir, you had told in the earlier class, but can you please once again give the definitions for FDN and FON?
Okay. So Raju, can you do you have slides, right?
Yes, sir. Wait.
Yeah. Just find that. It is in I think lecture 15. I think lecture 15, Raju.
The lecture 15, sorry. Yes.
Yeah. So here, what we are saying that there is a typo here. It is not FD, right? It is PD. Okay.
Then wait.
No, I think I did not correct it. I think. It should be PD and PO. By mistake, I have written here FD. But this is a typo. This is a typo.
Okay, so you can see that this PDN means the number of partitions of n into distinct parts. So as we have written here the generating function, you can see that after distinct parts means you can't take any number more than once. No repetition is allowed. Example, like we are going to find out the partition of 5. So see, this won't work. 3 plus 1 plus 1 because we are taking one
is
more
repeated.
once. Yeah. So
Yeah, similarly 2 plus 2 plus 1, this will not work because 2 is repeated. So you can see that after the last 4 will not work. So only first 3 will work because first 3 has the different digits. 5, 4 plus 1, 3 plus 2, right?
So this means PDN, and the PON means that you have to take only odd numbers. The partition of n into odd parts means you have to take only odd numbers. Means 2 to 1. Here 2 is even, so it won't work. This 3 plus 2 won't work. This 4 plus 1 also. So only 5, 3 plus 1 plus 1. All these three numbers are odd. So PON means only you have to take odd numbers, and you can take more than once also. Okay. So only odd numbers are allowed, and repetition are allowed, but with only odd numbers. And PDN means you have to take only distinct numbers. Okay.
So in this case, if you find that PO or 5, then it will be only 5. This 5 is odd. Another one will be 3 plus 1 plus 1. Here all are odd. And another one will be that 1 plus 1 plus 1 plus 1 plus 1. So here you have 5 odd numbers, right? So therefore in this case PO5 will be 3. Okay.
Okay, sir. Thank you, sir.
Okay. So you can ask any questions, you can ask, because here we are here to clear your doubts. So if you have any questions regarding this lecture, please ask.
Sir, if in any question it is not specified that we have to use pi or generating function, then we can do it by any method.
Right, but we will mention either you should apply generating function or that inclusion exclusion formula. We will mention that. Because actually writing a solution is fine and it should be allowed, but here we want to restrict. Otherwise, actually the main reason is it is difficult to check a answer sheet because there are many students, right? So if I do not specify anything, then more than several students will have different solution and it is difficult to check. For that reason only I will specify. And there is another reason for that. So we will also understand that the students should understand what is a inclusion exclusion formula and what is a generating function, all of this, right? So we will specify that. So don't worry about that, we will specify that.
Sir, if we are asked to prove something, then we can use combinatorial proofs, right? Like if it is not specified how the proof is to be provided.
Right. So if we do not, suppose if it is nothing is provided or nothing is mentioned, then you can use anything. But generally here we will ask that use, for an example, if we want that Pigeonhole principle, then we will mention in the question that by using Pigeonhole principle prove this. Then you have to give that argument. The one reason is we want to know that for an example Pigeonhole principle you understand or not. So this is one reason. And another reason I told you that if several students have several solutions, then it is difficult to check.
Okay, sir. I mean, my first like the concern question that triggered this doubt was that question regarding the number of surjective functions.
No. For that you
them,
can use anything. For that you can use anything. For those
like
type.
a combinatorial proof is like the argument how we are counting. A counting argument is much more simpler than any other.
No. That is fine. There you can use anything. The main thing is what I am saying when we ask, say, to solve a recursive relation, we will ask that using generating function. So you have to use generating function for that.
Okay, sir.
Okay, and for suppose if it is application of Pigeonhole principle, because I see Pigeonhole principle is very easy. So we will not ask that, okay, by just you can use any argument there. But what we want to write, want to have that pigeon principle, that solution in such a way that you should mention that what is pigeon there and what is whole, so that you are applying pigeonhole principle.
And sir, if there are times that we cannot really distinguish what is pigeon and what is whole, or rather it takes us much more effort than distinguishing that, like for example, there.
So you should understand, right?
Yeah,
Because
means
what
like the
is
kind of argument. Can we provide the same kind of argument that the pigeonhole principle provides? Like
No.
there was a question
That-
in tutorial 6 that mentioned that
right. Yeah, but we will not allow actually that one. So we will mention that by in the question we will mention that by if we give that the application of pigeonhole principle, then we will mention that. So by using pigeonhole principle, prove this.
Okay, so we need to identify what are pigeons and what are holes in there.
Yes.
Okay.
So like in this problem 3, do we need to write the solution in this way, like making a set of this and this?
I did not get actually your question. Raju, did you understand what he is saying?
Sir, actually in tutorial 6 there was a question, I guess question 3, regarding counting of like fruits. So in that kind of question, it wasn't much. Tutorial 6.
Okay.
I think there is a theory in the class in tutorial 3 that if there are odd numbers, if odd numbers are given and you need some set with this kind of element, then you will have at least this number. Right? That means, Kavita, please share this.
Yes, I have shared the screen. We can discuss it.
No, not this one. She is saying tutorial 6.
Yeah, this one only, this question only.
Question number 3.
Like, yeah, here it wasn't like even in the solution we did not mention what are pigeons and what are holes exactly. But like we know we are using that argument, and for our counting we can provide the similar statement to the pigeonhole principle that considering like apples and bananas and oranges, then we have the maximum distinct kind of thing, and when we put another fruit, then it has to be one of these 3 categories. And that kind of argument, if we provide that, or do we actually need to identify what are pigeons and what are holes?
Yeah, what I am saying that it is better to always write what is pigeon and what is hole, because we want that one only. But don't go through the tutorial sheets, because in the tutorial actually we planned it is to give only the solutions. Solution means it is not that explicitly written or something else. So they miss, it is not miss actually, they give just the idea and short proof. This is just a short proof. But when we give a questions, I think it is better to write what is pigeon, what is hole, so that you can use the pigeonhole principle.
Okay, so if in this particular question, if I were to write pigeon, what are pigeons?
But in this case, it is just a use of that theorem, right?
Yeah, like that's why I was saying that it uses pigeonhole principle, but what exactly are pigeons and what exactly are holes, it is not like
No,
identify.
right, but no, exactly, because it is the generalization of the Peace principle, the next theorem.
Yeah,
What?
okay. So if we are using
Yeah,
generalization,
in
then
that case you
we,
don't. Right. In that case you don't have to write anything.
yeah, okay. Okay, sir.
But try to find that what is pigeon, what is principle.
Yeah,
Sorry,
of
what
course,
is theorem and
that's
what
the
is rule.
first priority. But if there is a
Right.
generalization, then we can
Then
like,
yeah, it is difficult to find what is pigeon, what is rule. Yeah, I understand
yeah,
your
okay.
yeah. Yeah. So any other query?
Sir, in recursive relations, could you solve an example in which there is a product of two terms like an into n minus 1 instead of like a an is equal to something plus fn, like an is instead of a linear homogeneous part, could you take a could you solve an example that has a product maybe, or is that not in the syllabus per se?
No, it is not in the syllabus. Means syllabus. We will define the syllabus first of all. So actually, as I told you earlier as well, because this is not a course on combinatorics. Okay, so this is a course on 4 different topics. So therefore, we will not go to the details of all the parts. We are just giving the idea. So we are giving just idea what is combinatorics and what are the problems are. And similarly, we will give the rough idea of graph theory. So we will not go into the details of each and everything. So since we did not give the products, we will not ask during exam. But this is just the first course. So if you want to learn more on combinatorics, there is a course on combinatorics. Then you can learn all of this stuff. Okay, so here we are giving just idea and the basic problems, not the hard one.
Okay, sir. Thank you.
Okay, for this course. But obviously, it is not. It does not mean that it is not in the syllabus. But here we are not doing that.
Okay, sir.
Because syllabus we will define the syllabus, right? But what I believe that this is a course with 4 different topics, because there is no relation with combinatorics with logic, right? So this is a part of 4 different portion of discrete mathematics. So in this course we are giving that idea for each one. So therefore we are skipping most of the part of combinatorics, we are skipping most of the part of the graph theory, and we are giving just the basic ideas and the basic problems. Okay, so product will not be in the during exam, but obviously so see in any book, then you can read from that one, because now you know combinatorics, so you can read by yourself a little bit if you want to know more. Okay, and in that case, if you have doubt, also you can ask to us. You can discuss with us. That's when you can discuss with me. You can discuss with your TA. That is fine. We are always here. Okay, so any other query? So I think there is no query then. Okay, so if there is no query, then we can stop and see when the next one, 11th, when we will. So you will give the exam.
We should wait 2-3 minutes because maybe someone
Ha
else.
ha. Yeah. We can wait. We can wait. Yes. So we can wait and then we can then stop the meeting. So okay, so we will waiting 2 minutes. So if you have any questions within these 2 minutes, and you can ask, then we'll extend more. Raju, so I think we can stop, right?
Okay, sir.
Okay, students, thank you, and see you in the next day, Thursday, no? No, Monday.
Thank you, sir.